Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my grade 8 students. It's a very cold day, so I've got my heavy jacket on. Anyway, as promised, today I'm going to upload the video that summarizes lesson 2 and lesson 3 of light and optics. Okay, so I want you to pay attention, please. And the point of this video is that if you didn't understand anything in class, or if you missed out on some sessions because you were absent, you can always refer back to these videos, go back through them, and also help you answer the questions as well. And I would like to think that you would have answered these questions already, and so you have a chance now to actually fix your answers or go through your work if you need to. Right, okay. So let's start with page 104. And what I'm going to do is I'm going to read through the page and then summarize it and answer the questions as we go along. So periscope in a submarine, hidden beneath the ocean surface, a captain peered into the long tube to see possible threats in the sea and the air above. So this sight tube, called the periscope, was designed by Frenchman Mary Davy in 1854. Davy's periscope contained two mirrors, one placed at each end of the vertical tube. The mirrors were set parallel to each other at 45 degrees to the vertical. The reflective surfaces faced each other. When light from an object on the surface reflected downward, an image appeared to the eye. People in the submerged submarines could see what was above them. So the way this works is basically a periscope is a device that allows you to see objects that are not directly in front of you. And so it's basically like just a bunch of tubes that are connected together in such a manner. Now it has at least two mirrors, one here, okay, and one here. And so if we consider this the surface of the water, and the submarine is under the water, obviously, right, and there's a person watching over here, okay, and excuse my amazing drawing skills. Right? Now that person, what can they see? They can actually see the image that is of the object above the water. Because what's going to happen is the light rays are going to go. Can I just use a different color pen? I'm going to use sky blue. So what's going to happen is the light rays are going to go through the periscope. They're going to be reflected by the mirror at 45-degree angle and going to be reflected once again into the person's eye, and they're going to see the object. And that's the way it works. So that uses reflection. Okay? So what are some of the things that the person might see? Some of the things the person might see include ships. Okay, so let's have a look. Maybe ships. What else can they see? They can see swimmers. People are swimming. What else can they see? Land, so islands. They can see whales. Well, they can see that under the water as well, maybe. Icebergs would be a good one. Icebergs, okay, and icebergs that has an E in it, and so on and so forth. So basically, this uses reflection. So we have one mirror here and one mirror here, and what happens is they reflect the light into the person's eyes. So immediately, two things come to mind. In order to see something, in order to be able to see something, you need two things. You need light and you need eyes. Okay, so the eyes act like a camera, while light actually reflects off the object into your eyes. Okay, and we'll explain that a little further as we go along. So what are the kinds of reflections? Well, we would like to basically divide or categorize reflection into two different distinct categories, and those are diffuse reflection and regular reflection. And we'll talk about that in a minute. So light, as you already know, travels in straight lines, which is very convenient because then we can use it for all sorts of things. And let's have a look. So what happens with regular reflection? So with regular reflection, light stays parallel. So the light rays stay parallel and you can see the image quite clearly. So that's the kind of reflection you see when you look at your image in the water, or when you look at your image in the mirror, or you look at your image in the glass window, or any smooth surface, right? So that's the kind of reflection that you see. Why is that? Because, well, let's have a look. So that's your face, all right? Let's assume that's your face. And when you're looking through a mirror, okay, so let's say that's a plane mirror, and plane just means flat mirror. What's going to happen in regular reflection is that it's not going to fuse the light, and so it's going to continue traveling in straight lines. And so your image is going to be more or less exactly the same as it is on the side. And the reason for that is because light isn't diffused. It's still traveling in straight lines because it is a completely regular form of deflection or reflection. Okay, now this is a simplified image. Obviously, the image actually is reflected into your eyes, but because this is just the introduction, I will avoid that at the moment. Okay. Right, so let's have a look. So we've got regular reflection, and that's the kind of reflection that we see in water, we see in smooth surfaces. What about the other form of reflection? That's called diffused reflection, And that's the kind of reflection that happens with every single object, right? Unless the object is completely transparent. But basically, most objects that you see, well, they show a form of diffused reflection. The reason you are able to see an object is because light hits it and then reflects into your eyes, right? So you might not be able to see your face clearly in the wall, and the reason for that is because it diffuses the rays from your face. So light hits your face and then it goes into the wall, and then rather than being reflected in a straight line, in parallel lines, what happens is it gets diffused, and so it loses focus and you can't see your image in the wall. Now, someone might ask and say, well, hang on, sir, like the desk is quite smooth, but I still can't see my face in it. Well, the thing is, microscopic bumps matter in this case. You see, light rays can be quite small, and so it really matters how smooth it is under a microscope. You might not be able to see how smooth it is. You might think it's smooth, but in fact, it's quite bumpy. And if you look under the microscope, you'll see all sorts of rough surfaces and edges and that sort of thing. So when that happens, you get this image over here. So you get light rays that are scattered or diffused, and they go all over the place. So so in fact, this is a form of diffused reflection over here. So this is diffused. So this is diffused reflection, while this here is regular reflection. Okay, and that's what we're talking about. Oops, excuse me. And we're back. Sorry, just took a little break there. Okay, Bismillah ar-Rahman ar-Rahim. So the next point here is that we were talking about diffuse reflection, and we said diffuse reflection is one where light rays do not reflect in a regular way. They're not parallel, they go all over the place, and so the image is not clear, which is the reason why you can't see your face in the wall. Okay, what types of images do mirrors produce? And well, a plane mirror produces what we call a virtual image. Have you ever looked at yourself in a curved mirror of a fun house? If so, you know that your image looks different than it does in a flat mirror. Okay, your image may look tall, skinny at one point, and short and wide at another point. To understand why your image changes, you need to learn about the types of mirrors. Okay, types of mirrors. And we basically have three types of mirrors. We have the flat mirror, okay, and we always draw it this way so that the smooth part, the mirror part, is the one without lines. Okay, so that's the flat mirror. Then we have something called the convex mirror, okay, and I'll tell you how to recognize these in a little while. And then we have the concave mirror, okay, and that one looks like that, and you can see the smooth part on the side. And I'll tell you all about what these share in common and how they're different as well. Okay, so let's have a look. To begin with, I'm going to highlight a few things here, and just a second. Okay, we're still recording. Very good. So to begin with, I'm going to talk about plane mirrors. Did you look into a mirror this morning to brush your teeth, for example? If you did, you probably used a plane mirror. A plane mirror is a flat sheet, so it's flat, so it looks like a piece of paper, right? So it's just flat. Okay, that is what a plane mirror looks like, just completely flat. Um, Often the coating is on the back, and so the silver side is on the front, so you can actually see yourself. Now, let's talk about those things here. Because the coating is smooth, regular reflection occurs and a clear image forms. The image you see in a plane mirror is a virtual image. The image you see in a plane mirror is a virtual image. So when you're looking at yourself in the mirror, okay, and the image that you see looking back at you is what we call a virtual image. What does the word virtual mean? Virtual means not real. So virtual means not real. So why is it called a virtual image? We'll come to that in a minute. An image that forms where light seems to come from is called virtual. So it seems like light is coming from the back behind the mirror, but in reality, there's nothing behind the mirror, right? As you already know. So since there's nothing behind the mirror, there's no actual light source behind the mirror, we call it a virtual image, right? Your image appears to be behind the mirror, but you can't really reach behind the mirror and touch it. So that is, I'm just going to highlight this, highlighter. So a virtual image is an image that forms where light seems to come from, okay? That's the first thing you need to understand. Virtual describes something that does not really exist. And what we mean here is that obviously this image of yourself, this image here, this doesn't exist. It actually comes, it's in your eyes. The light reflects off the mirror and comes back into your eyes, but if you look behind the mirror, there's nothing there. Your image appears to be behind the mirror, but you can't really reach behind the mirror and touch it. A plane mirror produces virtual images that is upright and same size as the object. So 3 points there with virtual mirrors. The images are virtual. Oops, what is that? Okay. Virtual. I don't know why suddenly it does that. I have no idea. Oh, it's still on highlighter. That's probably why. Okay. Virtual, upright, and same size. And that makes sense. If you look at yourself in the mirror, you see same face and it looks the same size and it's upright. Upright means standing up straight. Okay. Pretend that your friend has never seen her image in a plane mirror. How would you describe to her the similarities and differences between her image and the real her? Well, the image is the same size. That's the similarity, same size. Right? What else? Same size. What else can we say about her image? Her image is, well, I mean, we can say it's the same details, same color, same details, except what is different? What is different? The difference is that although it's very similar, the difference is that it's inversed, which means left is right and right is left. So that is, and right is left. So that is the difference really. Okay, let's have a look at concave mirrors. Concave mirrors, they're the ones where the mirror is on the inside surface. Concave, as the name suggests, it's like a cave. So the mirror is on this side and the back side is the black. So if you put an object in front of a concave mirror, right, what it does is it has two options. Either it can produce a virtual image, okay, which is behind the mirror, or it can produce a real image, okay? And that's when the light rays actually meet. Like you're not looking at something that's in your eyes, but that is something that actually exists when light rays actually meet. So a mirror with a surface that curves inwards like a bowl is called a concave mirror, all right? So we already know that. They meet at a point. Notice that rays of light shown are parallel to the optical axis. So parallel to the optical axis means they are parallel to this line over here. And parallel just means they run in a straight line. They never intersect each other. But once they hit the mirror, what happens? Once they hit the mirror, they reflect off the mirror and they are intersecting with each other. Now this point of intersection, this point here is called the focal point. And the focal point means the point at which they all focus. Okay, the focal point. Okay, let's have a look. Concave mirrors can produce real or virtual images. They can produce both, real or virtual. And really the point here is that it depends on where the object is. Okay, so if the object is somewhere beyond the focal point, then it produces a virtual image that is enlarged. But if the object is before the focal point, then it produces a real image, and it's going to be also enlarged, but it's going to be with slight limitations. And we're going to talk about that. So a real image forms when light rays actually meet. If the object is further away from the mirror than the focal point, the reflected rays form a real image. So if it's over here on this side away from the focal point, then it produces a real image. Okay? Unlike a virtual image, a real image can be projected on a surface like a piece of paper. Okay, so that's something you actually can see projected on a piece of paper, not just in your eyes. Real images are upside down. In this case, a real image may be smaller, larger, or the same size as the object. Okay, why could it be smaller? Well, here's the deal. If this is an object over here, Hangul, this is an object. Then basically, if the object is over here, then the image can be over here, and this is what the image would look like. But if we extend this further, then the image can be the same size, and if we extend it further, then the image can be even bigger. So it can be the same size, it can be smaller, or it can be bigger, as long as the object is behind the focal point, as long as it's over here somewhere. Okay? Now, what if the object is over here? What if the object is over here? If the object is over here, then the image is always going to be virtual and large. Why is that? Well, this is what we experience in this case. In this case, what we experience is this sort of thing. And so the image is going to be upright, and it's going to be large, and it's going to be virtual. So, two things. If it's before the focal point, or it's before the focal point, then it's going to be real, upside down, and it's going to be either smaller, same size, or what? Or bigger. But if it's after the focal point, it's going to be virtual, and it's going to be bigger. Okay? So the type of images that is formed by a concave mirror depends on the location of the object, as we have just already said. So here's an example. An object is over here, while the image is over here. And of course, since the object is behind the focal point, or before the focal point, this is the focal point over here, هذه الfocal point, right there, that's the focal point, and the object is over here, so that means the image is going to be upside down. As you can see, it's different, it's flipped, so it's upside down. It's going to be real, and it's going to be, in this case, smaller, right? Over here, the object is also behind the focal point. This time it's also upside down, but in this case, it is larger, okay? So here it's upside down, oops, and it's going to be larger, and of course, it's real. Over here, it is upside down, and it's going to be smaller, and once again, it is real. What about the last one? The last one is in front of the focal point. The object is in front of the focal point. So the object is, this time the image is not upside down, it's upright. And it's going to be larger. And finally, it's going to be behind the mirror. So it doesn't really exist. So it's going to be virtual. Okay, or not real. Okay. Let's move on to convex mirrors. So convex mirrors, here we have another type of mirror, and it looks like concave mirror. So here's the thing that I want you to understand as a student, is that concave mirrors can be on this side or this side. The black side can be on either sides on the outside, as long as the shiny part is the one that's curved inwards, then that means it's going to be concave. With convex, they can also be like this or like this, but this time the black side or the dark side is the one on this side, while the one on the side that's curved outwards is the mirror. So that's what a convex mirror looks like. With a convex mirror, it's slightly easier. With a convex mirror, it only produces virtual images, which means it's behind the mirror, and they're always smaller than the real object. Okay? And I remember showing you this video in class about it. So if I have an object over here, and then I have a convex mirror, what's going to happen is the convex mirror is always going to produce, so I have a beam of light coming out of here and a beam of light coming out of here, right? So that's going to be reflected this way, and this is going to be reflected back this way. But here's the thing, the image is going to form over here. The image is going to form over here. So you can see the image, and the image is going to be virtual, and it's going to be smaller than the object. Okay, so it's going to be virtual because it's behind the mirror, and it's going to be smaller than the object. Okay, and that's how you do that one. So when we let's answer this question here. It says compare and contrast the shape of a convex mirror with a concave mirror. So the convex mirror curves outwards, while a concave mirror curves inwards. Okay, so convex curves, oops, that's supposed to be a U, curves, oh, let me just start over, outwards, concave, curves, inwards. Okay, and let's have a look here. So it says here we have a challenge: extend the two reflected rays in such a way that we can actually see the image. Okay, so we have those two rays coming out of the bottom. So if we extend them like that, then we can see that they meet over here. So that means the bottom is now over here, and that is what it looks like. So the bottom is here. This bottom here is now over here. That's the bottom, and the head is now over here. So it's still the same size. It's still upright. It's smaller, obviously. It's still upright, which means it's the same direction, but it's smaller. Okay? Let's go through this table here. With a plane mirror, is the image real or virtual? Obviously, with a plane mirror, it's behind the mirror, so it's virtual. Is the image upright or upside down? It is, in fact, upright. And what is the size of the image compared to the object? Same size. And that is the normal mirror. What about the concave? A concave mirror, further than the focal point. If it's further than the focal point, it's going to be real, and it's going to be upside down, and it's going to be either smaller, equal, or bigger. And if it's closer to the focal point, it's going to be what? It's going to be virtual. And it's going to be, whoops, sorry. It's going to be virtual. It's going to be, is the image upright or upside down? It's going to be upright. And it's going to be bigger. With a convex mirror, it's always going to be virtual. Oh, I can't write on here, unfortunately, because these prompts keep coming up. It's going to be virtual for a convex mirror. It's going to be upright as well, and it's going to be smaller. So I can write that. Smaller, upright. I'm just going to write it over here, sorry. And it's going to also be virtual. Okay. Right. Let's have a look over here. Classify the types of mirrors and is in the top photo. Right, each of the photos shown shows an application of curved mirror. A bus driver uses the mirror in the top photo to check for traffic. A boy uses the mirror in the bottom photo to put in contact lenses. So those are two different applications. Which type of mirror, which type of curved mirror is in the top photo? So that's definitely a convex mirror. Why is that? Because it makes the object smaller. It makes the object smaller, and it's what we call a wide angle lens almost. So it makes the angle smaller. It makes the object smaller, but it's still upright and it's virtual. What about the bottom? The bottom is a concave mirror, and obviously the boy is standing or sitting or watching himself at a point before the focal point. So here's the focal point, and his face is before the focal point. So between the mirror and the focal point, which means he's upright, he's virtual, and he's enlarged. So this is concave. Explain why the mirror in the top photo is more useful than a plain mirror for checking traffic. Well, you can see more. You can see a larger area. So that would probably be the biggest benefit in this case, is that you see a wider angle. Wider angle, so you see more. Angle, so you're able to see more. Right, explain why is the mirror in the bottom photo more useful than a plain mirror for putting in contact lenses. Well, it enlarges your eyes so you can see more clearly. More clearly. Okay? Okay, let's assess your understanding. The first one says define what is a copy of an object formed by reflected or reflected rays of light. Okay, so obviously that is an image. Define an image. An image is that. Next, classify a what mirror can form real and virtual images. A concave mirror, and it's the only one that can do that. Concave mirror can form real and virtual images. What mirrors form only virtual images? Plane and convex. Apply concepts. Which type of mirror would you use if you wanted to project an image on a screen, and why? Well, the only mirror you would be able to use is a concave mirror. And why that is because concave mirror is the only one that actually reflects light images and forms real images. So with a convex mirror, if you had an object, it would actually disperse that light, and in fact the image would form behind the mirror. But if you wanted a real image formed on the screen, then you'd need a concave mirror, as it can produce real images. Produce real images. Okay, and that's what we need to do to write there. Two types of images produced by mirrors are real and virtual. Okay, let's have a look. Ooh, okay. Here we have what looks like a quick reflection. Let's see if we can answer this together. Write the letter of the correct answer on the line at the left. So what I want you to do is I want you to try and answer these and then listen to me answering them. So try and answer them before me. Pause the video if you have to. A plane mirror does it have curved surface? No. Does it have a focal point? No. Once again, it doesn't have a focal point because the rays do not actually focus at any one point. Does it have diffuse reflection? Once again, no, it has regular reflection, so it has a flat surface. So that is D. Number 2 says most objects reflect light strongly, diffusely, smoothly, or adequately. Remember we said that most objects diffuse light, and the reason for that is because most objects are not shiny. So they diffuse light, which means they scatter the light rays, and that is why that is B. Question 3 says a convex mirror can produce. Remember, a convex mirror is this one here. So the mirror side is on here. It can produce smaller images and they are virtual. It cannot produce real images. So immediately we know the first one is wrong, the next one is wrong. Convex images, no such thing. There's no such thing as a convex image, so the answer for that one is D. Okay, and the last one. A concave mirror can produce, now that's the one that can produce both real and virtual images depending on where the object is, if it's before the focal point or after the focal point. So it can produce both real and virtual images. Fill in the blank to complete each statement. A convex mirror convex curves outwards, concave curves inwards. The what divides the mirror in half? Oh, that's a tricky one. There's a line. We call that the optical axis. Okay? And what forms where light seems to come from? What forms where light seems to come from? So if it forms where light seems to come from, then it's not real. It seems to come from. So we're talking about a virtual image here. A virtual image forms where light seems to come from. So that's behind the mirror. A concave mirror curves inwards. Rays parallel to the optical axis meet at the focal point. Because if they are going to meet, they meet at the focal point. Okay, and finally, the type of image formed by a concave mirror depends on whether a reflected object is located before the focal point or beyond the focal point. Or, sorry, between the focal point. In this case, it's going to be between the focal point and the mirror or beyond the focal point. Between the focal point and the mirror. So that's what that's saying, is that if the mirror is over here, if the object is over here somewhere, then it's going to be virtual and enlarged. And if the object is over here, then it's going to be real. And however far away it is, it could be smaller, bigger, or the same size. Okay, and with that, we've just finished lesson 2. Inshallah, in the next video, I will cover lesson 3. Adios, over and out.